Space travel, one of humanity's greatest achievements. But how exactly does space travel work? What does it take to get a spacecraft from Earth and into the vast, unforgiving reaches of space? Today, we're going to break it down and explore the science and technology that make space travel possible. First, let's start with launching a spacecraft. To leave Earth's atmosphere, we need a tremendous amount of energy. This is where rockets come in. Rockets work on a principle known as Newton's third law of motion. For every action, there's an equal and opposite reaction. When a rocket's engines fire, they release hot gases downwards, and in turn, the rocket is pushed upwards. This force is called thrust, and it's what lifts the spacecraft off the ground and into space. Rockets are built in stages. Each stage has its own engines and fuel, and once the fuel in one stage runs out, that stage detaches to reduce weight, allowing the remaining stages to continue their journey. This is why rockets look like they're shedding parts as they climb into space. It's all about efficiency and making sure the spacecraft has enough energy to reach orbit. Once the rocket reaches a certain altitude, about 100 kilometers above Earth, it crosses the boundary known as the Kármán line, which is considered the beginning of space. At this point, the rocket no longer needs to fight against Earth's atmosphere, and the spacecraft is now officially in orbit or on its way to its destination. Spacecraft are designed to protect astronauts from the extreme conditions of space. Inside the spacecraft, there's life support systems that regulate oxygen, remove carbon dioxide, and maintain temperature. In space, there's no atmosphere to block harmful radiation, so spacecraft also have shielding to protect the crew from cosmic rays and solar radiation. Once in orbit, the spacecraft is moving at incredibly high speeds, about 28,000 kilometers per hour, 17,500 miles per hour, to stay in orbit. This is crucial because, in space, there's very little gravity to pull objects back down to Earth. Instead, the spacecraft is constantly falling towards Earth, but because it's moving so fast horizontally, it keeps missing the planet. This creates a stable orbit where the spacecraft essentially falls around Earth instead of straight down. Now, if the spacecraft is heading beyond Earth's orbit, like to the Moon, Mars, or other planets, things get a little more complex. Interplanetary travel requires careful calculation of when to launch, because the planets are constantly moving. To reach another planet, spacecraft use a technique called a gravity assist, where they use the gravitational pull of planets or moons to boost their speed and change direction, saving fuel. For missions that involve docking with other space stations or satellites, precision is key. Spacecraft need to match their speed and trajectory exactly to ensure a safe docking. This is often done with thrusters, which allow the spacecraft to make small adjustments in its position. Finally, returning to Earth is another challenge. Spacecraft must slow down to safely re-enter the Earth's atmosphere, and this is where heat shields come into play. When a spacecraft re-enters, it's traveling at thousands of kilometers per hour, creating immense friction that heats up the spacecraft to extreme temperatures. Heat shields protect it from burning up during re-entry, allowing it to safely land. So, space travel is a complex mix of physics, engineering, and precise calculations. From launching off Earth to surviving the harshness of space, to safely returning home, it all comes down to the amazing technology that makes it possible. Whether it's exploring the Moon, sending rovers to Mars, or planning missions beyond, the future of space travel is an exciting frontier waiting to be discovered. Thanks for watching.